Welcome everybody to the Product Design and Manufacturing Collections and Nesting Utility. My name is Aldred Boyd. I will be presenting today. I'm an application engineer for Micrographics. And if there are any questions that you'd like answered afterwards, you're more than welcome to email me at that email address below there. So just a little bit about myself. I'm an industry specialist for the Autodesk manufacturing products. So anything that you'll find in the manufacturing collections, I should be able to know it and learn it and do it. So that's kind of what my role is in the company. I've got sort of coming on to 19 years of experience now. My forte is Inventor, although I have dabbled in AutoCAD electrical, AutoCAD mechanical. I've done some AutoCAD plant as well, and as well as the data management software Vault. So Autodesk Vault Professional is the top sort of niche product that Autodesk has for managing CAD data. So it's very CAD centric when it manages the data for you. I've got both. I'm certified professional for both AutoCAD and Inventor. So I've written my exams, and see, I've written my exams on that. So yes, I've also had to take exams just like you guys. I'm also an Autodesk certified instructor. So this is quite comforting, as you know, if you do comfort training with myself or any of my colleagues for that matter, we are all Autodesk certified instructors. So we know how, we know the software and how the software needs to be taught according to Autodesk and how they'd like it to be conveyed to their clients. I presented at the Autodesk University Extension in both Joburg and Cape Town, mainly focusing on Inventor and iLogic. So that's something that if you haven't done, it's a great way to automate your designs and your output for your designs for clients, like your drawings and things like that. So that's just something that helps you just ease the workload. You can automate 80 to 90% of your design through iLogic, and then just that 10% is the specials that clients would want. So if you haven't looked at iLogic, please, go take a look at it. It will really make your day. Okay, so the agenda. So just the nesting utility, getting started. So just how to get it, where to get it, and how to get going with it. Settings and workflows. So how do we start off with the nesting, and what settings do we need to take a look at, or options do we need to take a look at to get the desired results that we're looking for? Something that's just a little bit on it. People think, well, some people think that nesting utility equals Inventor. You can only use Inventor parts or sheet metal, but you can use your DWG and DXFs as well. So if you do have some legacy data that you want to bring in, then you can use that with the nesting utility as well. And then just preparing the nested parts for use with Inventor HSM. So what options do we have? Because obviously you've done this great nest, and then you want to put onto a little plate and actually cut it out in your CNC machine or your laser cutter or plasma jet. So we just take a look at that. And that, as you can see, can be done in both Inventor HSM, Inventor CAM and Fusion 360 CAM as well. Okay, Inventor nesting, what does it do? So basically what it does, it'll take your 3D objects from Inventor, your sheet metal parts or sort of solid parts with a flat face, and it'll take it and it'll extract the 2D shapes from your assembly of your part, or even DWG and DXF, and arrange it so that it maximizes the space that you get in your stock plate. So with the nesting study, you maximize that arrangement or optimize the arrangement so that there's minimal wastage. You don't want, when you buy a stock plate, you want to use as much of it as possible, because any scraps is actually money that you're losing. And then from that, you want to take your results, export it to Inventor CAM or Fusion 360 CAM for your cutting purposes. Who has access to it? So anyone who's bought a product design and manufacturing collections, and this has been available since 2019. So if you're still working on 2018, unfortunately you will not have this. And also it's not a separate, you cannot be purchased separately. So you must buy the collections to be able to access this technology. You can download it either through your Autodesk account or through the Autodesk virtual agent. And that's the web address, ava.autodesk.com. It's a great place to go get your stuff. You do have to be signed in to download as well. So with your Autodesk account, sign in and you'll be able to download that. So this is installed as a separate add-on. So what you need to do is you definitely need to install Inventor first before installing this add-on over there, the Inventor nesting. Okay, so the files that you can use for Inventor, what are valid files? So IPT, Okay, so sheet metal components. The sheet metal part has to have the flat pattern out. Okay, so you can't just, if you haven't unfolded that sheet metal component, it's not going to be able to extract that the nesting 2D shape. You can also have a simple sketch in your IPT file or your sheet metal component, or just a simple extrusion. And you can say, for instance, I want that extrusion, the shape of that extrusion to be what I'm going to be nesting. Inventor solids obviously must have a flat face. You can also have Inventor composites, and also once again has to have a flat face. And then you can also have non-native files. So basically imported files like sat step, saved as an IPT, and that also has a flat face over there. So that'll automatically be able to say, okay, right, I know that part, I can use that part, and let's go put it in to the nest. Then assembly. So this is actually quite a nice way of doing it. So if I've got an assembly with a whole lot of sheet metal components in it, or just generic CAD files in it as well, I'm able to then go and pull that into a nesting study. Okay. You can do DXFs and DWGs as well, but they need to be 2D closed shapes and must sit on a standard layer. And for a DWG, you cannot use paper space objects. So if you've got sort of anything drawn up or a shape drawn up on paper space, it's not going to work for you. Okay. Getting started. So what do we have to do that? Basically, first you need to download and install Inventor Nesting. So do that, as I said in the links above. And then also, after you've done that and it's got installed, be able to open up the files. So your IPT, IAM, DWG, and DXF. And then from that, it creates a nest document, so an iNest file. So that iNest file is separate to your IPT and your IAM file. So it's an additional file that you're creating, which is linked to your IPT or IAM to be able to create your nesting study. And there are 3 different methods of being able to just get to that iNest file. You can create an iNest file from the nesting ribbon. So this is when you've got no parts open and no assemblies, no parts, no drawings open. So if you've got nothing open, you'll see the nesting tab at the top pops up. Click on the nesting on the begin panel, and then it will start the whole nesting process. The second method is if you've got a part or an assembly open, if you right click on the name in the browser, it'll ask you, would you like to create a nest? Click on yes, and then obviously it'll take you to the next dialog box, the sources dialog box. Then the third method is to create a nest from the new menu. And that is, you all know this, file, new, and then you go down right to the bottom, you'll see there's a new standard.inest file or whatever template you've actually created for your iNest. Okay, so once you've done that, this next dialog box pops up and it asks you to create a new from a template. So if you've set up your template, you can go find that or add to an open document. So if you're already working and you've got an iNest file open, it'll list those and you can go and add it to that existing open document. Or you can add to an existing document that you've already saved. So you've previously worked on it maybe a day or 2 ago, and then you can go browse to this area and write, these shapes now have to be added to this iNest document over here. Okay, so when you're creating the nest, okay, so you go there, file, create new nest, you've chosen either your parts or your assembly file, then this dialog box pops up over here, your sources dialog box. That then goes and it gives you all the information of, where you're collecting the data from, where the data is saved, and then, for instance, the source provider. So that source provider, is it Inventor part or a generic part? And so you can just choose which one of those it is that you want. And then you've got the configuration as well. So that's how it brings in your lines, etc. And then your material name. So that grabs it from the part that you've actually got. It grabs the material name, including the width, so the thickness of the component as well. And then what it does, it maps from your source files to the iNest file exactly what you want. So if it was, as I can see, a rubber and wood maple, it maps it to a rubber and a wood maple in the iNest file as well. Once that's done, then it shows you all the parts on your screen. So those are all the individual parts that you've got. You'll actually see there's a little one over here on the left-hand side over here where it is, so there's actually 3 different types of material that I've actually brought in. These are the individual parts. There's not the complete amount of parts that you've got in the iNest, because there's many more, but those are in the properties of these different shapes that you've got over here. And these shapes are also just flat 2D shape. It's not the 3D components that you had when working in Inventor assembly or a part. Okay, so each of those shapes, if you right click on it, you get the following sort of options: properties, enabled, so rename, open, export, and create your 3D model. Now, with the properties, take a look at this over here. If you right click and select properties, you'll be able to go change the name. So if you slot stand top, that's actually the same name as the part. So it's nice to identify exactly what's going on. It also tells you how many you've got in there. And then you've got your priority as well. So priority is, you know, should it be nested first or should it be nested last? So obviously the lower the number, the less priority it has, and actually stick it into the nest while you're doing the nest. Would you like to mirror this part? Then you got your orientation. So the default orientation is 0 degrees. You can say, you know what, I actually think it'd be better if I rotate it about 90, 180, 270. So those are things that you can change with the properties. And then you've got obviously your measurements as well. And those just tell you information about, you know, the total length and width, the area, as well as the perimeter of the shape. Then you can also bind it to your material properties. So that means that it takes the properties from the material that it's coming from. You can say, look, you know, right, for this over here, I don't want to bind it to material properties, and I actually want it to rotate to 90 or 180 or 270. Also, what I want to do is you've got deviation increments. So if I rotate it to 90 and you say I want deviation of 60, then it will deviate either, you know, 90 plus 30 or 90 minus 30, and then increments of, you know, 5 degrees. So it'll go 90, 95, 100, 105, 110. And then you've got your pre-kit, and pre-kit, what that does, it shows, and it takes that shape and it kind of, in AutoCAD terms, would group it. So it acts as one, and it has to be all nested next to each other. Okay, so the next thing you got to kind of set up, you know, while you're going through this nesting study is the process material library. So what this does, it tells you what materials you've got to what packaging you've got. So the packaging basically is the shape and form of your raw material. So is it a big flat sheet or is it rolled? You know, so you're going to get like 20 meters of rolled sheet metal, or you're going to get 10 plates of, you know, 1.5 by 2 meters. And then the material is obviously comes from the source. So it's those 2D cut shapes that you've got. So with this, you'll see that I've got 4 packaging, but when I brought it in, there was only 3, you know, 3 materials that I brought in. That first packaging you can basically ignore. That's kind of like a generic standard packaging that's, you know, stuck in there. So you can actually just ignore that, the first one. It's the second, third, and fourth one, and so on, that you're actually interested in. This over here also just allows you to see what your material ID is, what the provider is. You can add a provider as well. So the provider is basically that material that's coming in. So if I had to go back to my original assembly now and select and write on stainless steel at 0.5 millimeters, it will then go and put you know, another provider over there. So another material ID with material and thickness and category and density, nesting color. So all of that over there, and the provider would be from Inventor, and then sync from provider as well. So if I do make changes, you know, it make change automatically. So I just going back to add from provider will go into my materials list of Inventor, and I'll be able to go pick it. I want stainless steel, I want aluminium, I want wood. Sync from provider is when I go and change it in the original assembly, and it will automatically update in over here. Then we've got our packaging over here as well. So with the packaging, that's the material that I've got, and it's mapped to the packaging. Okay, so I've got packaging 1, 2, 3, and 4. I can go change those names. So at least I then go and see, okay, right, packaging 2 is actually, you know, a plate of 2.54 millimeters by 1.270 millimeters. I can change that form from rectangular to roll. So then I can say a roll of maybe 20 meters, and this is the width and the thickness and stuff like that. And then you can also go put the cost in as well. So by putting in effective cost, or, you know, accurate costing, you'll be able to get a cost analysis out afterwards and see exactly how much you actually are kind of using and how much the cost is going to be. Okay, so once you've done that, and probably before you've done that, you've got to kind of take a look at your options as well. So the options is, it shows you the display of what you're going to see when you finally get the nesting study out. And as you can see there, this on the display, you've got the sheet geometry, dimensions, header annotation. So at the bottom in the preview, you can see there, header, the header is going to be at the top. So what's the font of the header going to be? So Homer, the size is going to be normal. So that's taking it from Inventor as well. And then the colors, what colors do you want? If my background is white, or my background is black, those colors are going to be quite important because you need to be able to see sort of what's going on and differentiate quite quickly. So just going through these different options over here. So the sheet geometry, if I've got 2 or 3 different sheets, then the X direction spacing and Y direction spacing, that's the spacing in between each sheet with all the different shapes on it. So if I've got 50 shapes and my sheet is say 1.5 by 2, obviously I can only fit a certain amount of shapes onto that sheet. So once that first sheet is full, it's going to create a second sheet. And that second sheet in the X direction space will be 9.84 inches. And if it put it down below it, it'll also be 9.84 inches. So that's just how it's going to arrange it so that when you look onto Inventor, everything's not cluttered up and too close. So you can see the difference between each of the sheets. Okay. So then the dimensions, as you can see there at the bottom there, packaging length, remnant length, nest length, and width. Do you want to see them? Okay. Yes or no? So you can just tick off enable to just take all of those away. Or do you just want to see the nest dimensions? You just want to see the remnant dimensions? Or you just want to see the packaging dimensions? Then the header. Okay. So with the header, there's certain information you've got at the top over there. And as you can see there, default, sheet name, material, packaging, sheet quantity, stack size, efficiency, packaging cost, total nested cost, and date. Now on the left, you can see that I've also got comment, nest name, sheet area, single nested cost, single remnant cost, thickness, time, and total remnant cost. So you can go and have all the information, sort of ready over there. And that's just like sort of the visual representation in your main drawing area in Inventor. But what you can also do is, there are reports that you can write out. So this information will also get extracted into your report. But, if you just want to, creating reports is, sort of further down the line. Once you've created your nesting study and you want to see that information very quickly, this is information that's going to be situated on where your sheet is going to be. Annotations, okay, so what annotations do you want? So once again, take a look at nest name, nesting efficiency, number of parts, number of sheets. And that is sitting, I think, on the left-hand side under the nest report summary. All of that's over there, okay. Then the next one you've got is your fabrication info and any etched text or etched boxes that'll put that on over there. So as you can see, just visually, there's a lot of information that you're able to draw out. And these are all controlled here with your options. And then the sources. Okay, so from the sources, that's actually right at the top. Your X direction, your Y direction. Is it shading the non-nestable contours? So one thing that Inventor does look at is if for instance, you've got a shape and you've got like a big space inside it, maybe something's going to be cut out. Sometimes what you might want to do is if you have a smaller shape, you want to stick it inside that shape. Inventor cannot do that. Okay? If you want to do something like that, you'd have to go through to something like TrueNest, which is in Inventor Nesting's sort of big brother. So what this does is it will show you those, those cutouts inside, but it doesn't take that into consideration if you wanted to nest something inside that. So that's that shading, full non-nestable contours. That's everything inside that. And then, sources arranged by material, and then your representation, would you like to see it in 2D or 3D? Okay, so when we do look at the, after it's actually nested, those shapes are all in 2D. Okay. Then your extraction, so you got your configuration file of the extraction. That extraction is the extraction of the 2D shape from your 3D shape that you're putting it from. And then you've also got an export configuration file as well. So that's, once I've done my nesting, now I'm going to take that, I'm export it through to a DXF because I'm going to take it to my CNC guy or my laser cut guy. And then he's going to go put it into his program. And, those programs, they read in colors and layer names. So this export configuration file, you can actually configure that so that all text comes out on this layer in this color. Your outer profiles come out in this layer in this color, etc. So that's where you can go and do that. So that it's easier for the guy doing the CNCing or the cutting to be able to configure that from the get-go. Okay, then you've also got a report as well. So the report template is sitting over here. You can go configure that report, and that will give you a whole lot of information which you can then sort of print out and just see exactly, listen, is this worth it? Is it not worth it? How much money we're going to make, we're going to lose, and get more accurate costs from that. Once again, Inventor's got your prompting. Would you like to autosave nest results if idle? That's kind of nice because, if you're sitting there and you're trying to do maybe hand calculations to see if everything's working out, and, ESCOM turns the power off, and then you've lost a lot of work. So you kind of want, visual reminders are always great. Autosaving is not the best thing for Inventor because you might autosave for hours and hours because you've got a really big assembly, but that's, you make the choice there to autosave and then not have ESCOM ruin all your work. Okay, prompt at nest completion. Okay, so once it's nested, would you like to save? Great. And display nest calculation warnings and error prompt. That's also quite nice though, that, if something's not, you're not able to nest something, then at least there's a warning coming up saying, great, listen, and you've got to go take a look and see why is it not being nested and that. Okay, and in the browser, just what information would you like to see? So the shape, name, and the sheet quantity. So that's just sort of something that you go on. Okay, so once all of that is done, so that's now your settings and everything like that, your options. So we've done all of that. We know exactly what it's going to look like. Now we're going to create our nest study. And with the nest study, the first thing we're going to do is create a name, which we are then able to go and sort of identify very quickly what this nesting study is going to be. A comment, little comment over there. Then you've got your job quantity. So if I've got I'm going to create a cupboard and it's got 50 parts in it. Now I want to make 2 cupboards. Obviously, I need to make 100 parts in total. So that job quantity, single value, I'm going to set 2, so I'm making 2 cupboards. Now, what happens if I'm making 1 cabinet, 1 table, and maybe a sheet metal cabinet of some sort? So there's 3 different assemblies that we've got. So if I click on the drop down next to single value, you'll see there's multi-value. And with the multi-value, it'll show me those 3 different assemblies that I've brought into this nesting study. And then I can say, right, I want 2 cabinets, I want 3 tables, and I want maybe 5 metal cabinets that I'm going to make. And then we'll go and calculate everything like that. Okay, then you got your stack size. So obviously, if you're going to be stacking up your plates on the CNC or the LaserJet cutter, then it will take that into consideration as well. You'll automatically manage nests and you automatically calculate nests. So with automatically calculate nest, as soon as I click on OK over here, it's going to actually start calculating the nest. Otherwise, if I'd have that not ticked, I go OK, I'm still then going to go and click on, go nest this now, please. And then automatically manage nests, it will then, it keeps a tab on your original files, your assembly files, your IPT files. If those change, then it's going to start getting little symbols next to the sources saying, something's changed over here, and then you have to go and make the choice to go and just re-nest it or refresh it. Okay, so on your shapes over here, so this just tells you basically your source, the shape, the material, the thickness, max X and Y, and then on the left-hand side, you can see they're selected. So at the bottom, you see 17 shapes selected. Now I can untick these. So if I say, look, I don't want the slot stand top and slot stand back in this nest, you can untick that. So it's not going to take it into consideration when creating this nest study. Then on the next tab, you've got packaging. So this is all the packaging that you've got over here. Now, everything grayed out, obviously you can't change over here. But on the right-hand side, you've got inventory quantity is infinite. Now you can change that. So if you know that you've only got 5 packaging 2s, then you can put in 5 over there. And what it does is, once it's used up that, then it'll have to go into the second packaging if you've created another packaging for that. So you can actually have kind of like an inventory stock over here. Very simple inventory stock management, but kind of, sort of going over there. If I click on any of these packagings on the right-hand side, I can delete it. Once I've deleted over here, any shapes that use that packaging over here will get unticked automatically as well. Okay. So if you think, okay, right, that I don't have any of packaging 4, delete it, and then at least then it's not going to nest over here. Okay, then you got your global parameters. So this is just a little bit of information about how it's going to nest. So the corner position, so your 0, 0, or your resting position, lower left, lower right, top left, top right. The minimum maximum runtime for the calculation. So if you know that after 400 seconds or 500 seconds, this algorithm is not going to re-nest it or optimize the nesting. It'll stop then. It will show you, this is what I've come up with. Okay? And the minimum runtime, 60 seconds. It'll run for at least 60 seconds, before it will stop running over there to get the desired yield, which is at 80%. Then you've got your remnant optimization, so minimum length and width. So what it tries to do, it tries to use everything. So most of the width and most of the length when doing the optimization. Then you've got minimum length as an option and the minimum width. So what it tries to use is either tries to use as much of the length as possible or as much as the width as possible when doing your nest. Okay, so once you've done all of that, you can actually go click run, and this is what you get. Okay, so with this, it'll show you how it's nested all those components. You'll see there's little numbers over there. So like little 1, 2, 2, 2, 2, 3, 4, 5, and at the bottom of it, it'll tell you what each of those shapes are. It also will give you the lengths and the widths of the components. At the top, there's just that general information I was talking about. So the sheet name, the material, the packaging name, sheet quantity, stack size, your efficiency, your packing costs, your total cost, the total nested cost, and the date that was run on. Then on the left-hand side, there's some more information, your nest name, the nesting efficiency, so that's pretty good, 74%. The number of parts is 32. Okay, so this is just one sheet of many. But you'll see the number of sheets is 3. So I've just taken a snapshot of the first sheet. Two other sheets to the right of this over here. The total nest cost is 3, and the total nested cost is 2.43. Okay, that 2.43 is taking into consideration how much material we are not using. Okay, so once you've done that, you want to control the nest display, and that nest display, you can see there shaded or wireframe. And then you've got your material as well, and you've got your object visibility. So with the material, you can take a look at the material and just say default. So it's just one color throughout. Then you can change the material as per source. So there's different sources. Each different source will have a different material. Same thing with the shapes. So different shapes will have different colors, a different segment. Your source orientation, so as it comes in, that's the source orientation. So you have different colors on that, and the nested orientation. So if it has changed, it will change the color if it has to reorientate while it's been nested. Any mirrored parts, it will then also show the difference in color for mirrored parts, and then material as well. So the different materials. So if you've got 5 different materials, you'll have 5 different colors. And then for the nest display over here, the object visibility, you'll see there you can look at the borders, dimensions, header, annotations, and fabrication info. So just untick any of those. You don't want to see the dimensions. It's not, not important. Then, you can take that off and you're happy to go. Okay, so once all of that has been done and you're happy with that, you can go and rerun your nesting if you wanted to, but once you're done with your nest, you're happy with it, then you can go run a report. So with the report, you can get things like, part preview, nesting properties, source parts, inventory, sheet details. Okay, so, with the, your nesting property summary, if I take a look at this, so just the job, material usage, optimization, positioning, grain, 90 degrees. So there's a lot of information over here which you can get out in a report as you, sort of after you've run it. Now your source parts. Okay, so great. The part name, the preview of it, how many have you got, orientation, grain, 90, 180 to 70. Is it mirrored? Did you force it to mirror? Deviation, increment, and the priority. Okay, so that's all information that comes out on that. Inventory. Okay, so you've got your inventory over here, and it's basically the sum 999, because I said it's all on infinity. So you kind of, once you've run your nesting, if you had to say like, packaging 2 was 5, packaging 3 was 2, and you've used that up, then it'll actually show up over here, sort of what you've got left. Sheet details, okay, so just sheet details and sheet properties over here as well. Okay, so just once again, it's kind of taking all the information that we had on the, after we did the nest and just putting it into reports that you can go and hand it in with the job or something like that. And then just your sheet items over here. So things like cost, area, perimeter, number of parts. Is it flipped, mirrored, the time, angle, and your part ID as well. And then you get some graphs as well. So you get a part cost pie chart, okay? Part counts chart. And these are all sort of dynamic. So, once you've run the reports, if I go and put my cursor on any of these, it'll give me like a little sort of a tool tip and it'll tell me exactly what's going on each of these different bars. Your efficiency and your cost chart, okay? So once again, a lot of nice visual clues on things like, say true efficiency, remnant true efficiency, total nested cost, and your total cost. So you can very, very quickly see exactly, cost to efficiency. What's going on here? Am I doing this right? Should I run another nest in, another nest? Maybe I can, sort of tweak some, some configurations and just see if I can get a better nest out. And then obviously run the reports again. Sheet areas chart, so your plate area, your nested area, your remnant area. Okay. And then this is quite nice though, because if you did have to run a nest and for instance, some parts fell, but didn't pick it up while you're actually creating the nest over there, it'll tell you what was excluded. Okay, so for whatever reason, maybe one of the sheet metal parts you had wasn't folded. Maybe one of the DWGs or DXFs had an open loop in it, or it had annotation in it. So it would then say, right, these are actually the parts, you thought that was actually in there, but it's not. So this is I think this is actually fantastic for the reports. Okay, so basically that's kind of the general workflow of getting from assembly and a part through to nest. I did say I'll talk about the DWGs, DXF. So just reiterate it. You can bring that in. So maybe it's old legacy, data that you've got. Where and one thing that's, as I said, you might have a failed part from a DWG because it's open. It must be a 2D closed profile. Okay, so if it doesn't work, then it's not closed. And geometry only. If you've got things like dimensions and text and your multi-headers or anything like that, it's going to fail. Okay, so just make sure it's like that. Also, with your DWG, make sure that it's on your model space and not your paper space. Okay, so to get it into your maybe an existing nest that you've got, you can see there I'll say sources at the top. You've got your source files and you go look for that DWG. When it brings it in, the material generic, and it defaults to material 1 because you think about it, it doesn't have a height, it doesn't have a thickness to it, whereas your Inventor components did have a thickness to it, your sheet metal parts. And then obviously once you've done that, then you can just go change the packaging and material for that to make sure that it's going to be nested quite nicely over there. Okay, so once that's done and everything's hunky-dory, you basically now want to take it out for CAM. So there's two different ways of doing that. So basically you can output it either to 2D or 3D. So the 2D export, it takes it to DXF. And once again, there you can see what happens. It brings up this export configuration editor. And you will then go and just configure that over there. So figure lines, layers, line types, whatever, configure it so that it's as easy as possible for the guy on the router or the plasma cutter to be able to just sort of do minimal amounts of modification before actually cutting out this part. Because as we know, time is money. And then for the 3D output for your CAM, there's two different ways: either multi-body part file or an assembly file. So the multi-body part file is quite useful because it's just one file. Okay, so it's not you're not managing 50, 60 different parts. You're actually just managing one file very, very easy. If you do take an assembly file, just note that you are going to be managing, quite a few different files. But if you do want to go and re-nest, move parts, maybe you think that, okay, look, if I move this a little bit or if I angle a little bit, it's actually going to make it a little bit better than the nesting. You can do that. So you take it out in assembly file. The way that it generates 3D models, you can either extrude the 2D shapes or use the 3D source if available. So it'll use, maybe the sheet metal components. So I'm not kind of duplicating that. Or you can just extrude the 2D shape. It creates everything from scratch. And then just with instantiation, excuse me, create instances for identical items. So think about when you do like a rectangular array or pattern, it's the same component, change one, or copy, change one, and change everything else. Create a group of instances for identical items. It will obviously do the same thing, but it'll put it into nice, neat little folders. So it kind of structures it quite nicely in your assembly. And then also each item remains a unique instance. So every single item is a separate component. Okay, that's going to make a lot of files. And then at the bottom there, you can see that you can also include your stock. And that's quite useful because, as you know, when you start with your CAM, then it will, you've got to say, look, what's the stock? How thick is this plate? So it does that. You can obviously manipulate it when you, you can either, choose it as a stock when you go into your CAM, or you can create new stock in the CAM. So it's totally up to you. Okay, and then once that is done, because Inventor CAM and Inventor Nesting is in the same environment, you just go to your CAM tab and set up your toolpath, create your G-code, and run with it. As I said, this can also be done in Fusion 360, so you can take your Inventor part, ship it into Fusion 360 if you're more comfortable with it there, and do it. But just remember that it is the same technology, both Fusion 360 and Inventor CAM. Okay, so in conclusion, basically, if you want to do anything, so you create a nesting study from your part file, assembly file, DWG, DXF, or generic model, so imported model. You set up your materials and packaging, you optimize your materials orientation, go to your options, see how it's going to be laid out, see how it's the colors, everything like that. Create and print reports for your nesting study to just double check and make sure that exactly what you've done, or what you think you've done is going to be what's going to come out on the outside. And then the last thing is output to DXF or 3D for your CAM in Inventor or Fusion 360. Okay. Great. Thank you very much for watching. Does anyone have any questions? Great. So thank you very much. This will be put up onto YouTube. If there are any more questions, I am in the Cape Town branch. That's our number over there. But you can email anyone, any of our 4 branches at Joburg, Cape Town, Port Elizabeth, or Durban, and we'll be able to help you out in any endeavors that you'd like to get onto. Thanks very much for watching, and enjoy the rest of your day.